known Don for a long time. I don't even know how long anymore. Through a former PhD student of mine, Candace Brakewood, we first met. But Don took a position at my alma mater, the University of Washington. So I'm called back there once in a while, and the two of us chat and enjoy hanging out together. So I was very excited when Don told me that he was going to be able to stop by for what I think is the first seminar that we've given since all of this craziness. So Don is an associate professor in CE at UW. He leads the Sustainable Transportation Lab, which develops and evaluates technical and policy solutions for making our transportation system more economically viable and environmentally benign, while providing opportunity or access to opportunities for all. His PhD is from MIT, but we let him come anyway. But he is a native of British Columbia, so he has some degrees from up there and is definitely a Pacific Northwesterner, whether it's the state or the Canadian side. So let's give Don a hand.
Thank you, Carrie, and thank you all for having, what an honor. Thanks for having me here, and what an honor that this is the first seminar. Like, wow. It's been a heck of a ride, and I was able to get out of part of it. I was on sabbatical last year. So I haven't even been through quite all the drama that I think some of you have. Anyway, I wanted to talk today because we're here. T-Score has sponsored the talk today, and so I wanted to talk about transit. And here's the thing: I actually don't do a ton of transit in my lab. I'll say a little bit about what we do, but we have been doing more on the ride-hailing side of things. So I looked for, and where we have been doing transit recently, it's mostly been at the kind of intersection of transit and ride-hailing. And probably, I don't think in nearly as interesting a way as I just heard some of you all talk about around the table upstairs. But I'll share what we've been doing, and I'll say a little bit more. I guess what I thought I'd do is give a very, very, very short intro to our lab. And I can say a little bit more about the scope of our work. Again, because we're ride-hailing and transit is sort of one little piece of it, and that's the piece I carved off for today. But we have been doing more in some other areas. And so the sort of two topics I wanted to talk about today are sort of two dimensions, two areas of interaction between transit and ride-hailing. One is at the sort of mode choice level, and the other is sort of curb operations and interference between ride-hailing and transit. And so that was kind of what I'll talk about. I think Carrie gave the marketing copy pitch on what our lab does, and I guess the idea it's that environmentally benign, access to opportunities for everyone, doesn't break the bank, and so we see sustainability as really a balancing of those three, and something that emerges from not just technology, but the interactions of technology with individual behavior as mediated by policy. So that's kind of the vision for what we do. That's not to say this is like a roadmap to every single project. Every project is usually much more like one little piece of this, but we try to, hit in all of these areas, where we can, in the aggregate. So that's kind of the vision. And we do, practically what that has meant for the last few years has been a fair bit of work on ride-hailing related mode choices. So whether it's choosing between ride-hailing modes in transit or choosing between private and pooled ride-hailing. We've also looked at the value of, done a fair bit of work trying to understand the value of travel time in these different modes to, sort of project ahead to a world where maybe if you have autonomous vehicles, how might that affect the financial cost of travel and the perceived burden on the traveler. And so we've done some stated preference work, we've done some actually really fun, and again I don't have the slides here today, we've done some really fun revealed preference work in that area where we had some data from a third party. I don't know why I'm digressing, but I think it's cool stuff. But we're looking at sort of third-party aggregator apps and able to see choices people make between ride-hailing and car sharing, and see a difference in the implied disutility of travel time there that we think has has some interesting implications. So we work in a lot of areas. I'd say right now we're trying to increase the amount of work we do on zero emission vehicles and associated infrastructure. So electric vehicles, not to the exclusion of hydrogen or other ZEV technologies, but really trying to ramp up what we do in the ZEV area, zero emission vehicles, particularly EVs and EV infrastructure. We're doing some work with WashDOT on infrastructure planning, trying to figure out how they can allocate resources to enable, reliable, convenient EV travel throughout our entire state. And so that's where we're trying to kind of ramp up more of our efforts as we go forward. I will say that I like to always start with an acknowledgement of the students, the undergrads, the masters, the PhD students, the research scientists that work in the Sustainable Transportation Lab, because they do all the heavy lifting, and I just get to kind of like bask in the glory of their efforts. And so if it weren't for these folks, right, I wouldn't have much to talk about today. And so I always like to acknowledge it as we go through. I'll try individual little topics to kind of identify the specific people who deserve the credit for the work. So the first thing I wanted to talk about was some work we've been doing looking at the effects of ride-hailing, and particularly autonomous ride-hailing prospectively on transit ridership, getting at this question of whether ride-hailing would be on net a competitor or a complement to transit by providing an access mode. And so it sounds like there's some very, very related work going on here, particularly with Pascal's lab, it sounds like. And maybe you all already have this, but I think maybe what we've been doing is more on the behavior side, so trying to parameterize people's choices and the sensitivity to like waiting time, travel time, etc. And we'll go through that. But maybe this can be of use to you. Maybe you've already got the answers. You can let me know. But this has been published in Transportation Research Record. The lead author is Malik Louie. He's a PhD student in our lab, and also very much helped on this work by Anushay Ranjbari, who was my postdoc, went to be a research scientist in Ann Goodchild's Urban Freight Lab, and is now going to be an assistant professor at Penn State. I don't know if you know her, Carrie.
I met her over the phone. I think
yeah,
you
yeah. She's really just an awesome researcher and an awesome human being, and was very, very key to this project as well. And then we worked with Ken Laberto at Toyota Research. He was sort of the sponsor partner on this work as well. So the idea here is that these are sort of three different ideas that we want to kind of keep in our heads simultaneously. Addressing this question of what's the net effect of ride-hailing on transit ridership, and how might that be affected by vehicle automation. So the first line of thinking is, look, ride-hailing competes with transit. It provides, one more door-to-door mode for non-car owners and for people who don't want to park. So some of those advantages of transit it brings, and it's therefore a competitor with transit. Alternatively, right, or in addition or simultaneously, ride-hailing may complement transit by providing an access mode for those who are not within convenient walking distance or cycling distance from want to cycle to the bus. It provides an alternative mode to access transit. And then, the sort of third idea is that automation may, draw more passengers into ride-hailing modes, whichever those modes are, whether it's solo, pooled, first, last mile. Automation could increase the attractiveness of ride-hailing by reducing labor costs and therefore fares. And so that was kind of the motivation for this work. And the challenge that we run into first off is that, when we try to think about automation, when we ask people about automation, you ask people about riding in an automated vehicle today, and they don't really know what that would mean. They're going to base that choice. You ask them, how would you feel doing this? They base that choice based on their perceptions of the technology today. And so this is work we did a few years ago and published. And so this is kind of earlier work. And in this case, we asked people to choose between driving themselves in their own car or being driven you know, and this was in the context of a commute, being driven in a ride-hailing vehicle. But in half the cases, we told people this is a ride-hailing vehicle, and in the other half, we said this is an autonomous ride-hailing vehicle. And what we found was that the implied value of travel time savings, this is a stated choice experiment, and the implied value of travel time savings went down in a conventional ride-hailing vehicle, which is consistent with the idea that you don't have to drive, and you know, it's less burdensome. Maybe you can do other things or just relax. But that's kind of what people think, and we have suggested. I know there's others who've dissented and said, hey, we shouldn't just assume that value of travel time, disutility of travel time is going to go down in an automated vehicle. But you know, our kind of working hypothesis is that it would. And then this is sort of consistent with that. But what we found is that if you tell people it's an autonomous ride hail, the implied value of time goes up. And so in this case, we didn't dig into why. We didn't ask them questions about their perceptions of safety or reliability or how much they would trust the autonomous vehicle. But we sort of hypothesized that this is like basically saying people are uncomfortable with the automation. Again, the only difference between this and this was here we told people it was autonomous, and here we I actually don't remember if we stated explicitly or just clearly implied that it was a human driver. So it's something to do with the automation. So this makes it complicated, and one of the things we're doing now, and I don't have results to share today, but one of the things we're doing now is when we do this kind of work, we ask people a bunch of questions about to try and elicit how they feel and how much they trust automation, vehicle automation technology, and then use that in a hybrid choice modeling framework to be able to control for that. But what we did in this case was we therefore asked people to make, so now moving on to the sort of the present work, we did it as a stated preference experiment that is based on people's actual self-reported commute modes. We recruited respondents by Amazon Mechanical Turk. We asked about their current modes and their origin, their home and work, approximate home and workplace locations. And based on that, we sort of in real time went and retrieved typical waiting time, travel time, and cost values for Uber, and transit mode characteristics and driving time from the Google Distance Matrix API. So sort of people give us this information, and then in real time we get that information back and use that as the sort of the pivot points in the stated preference experiment design. And the modes we asked people to choose among were car, transit, and ride hailing, solo ride hailing, like a private Uber trip, and then an Uber pool type of trip. People could, of course, report walking and biking, but it's a very small portion of our sample that reported walking or biking as their commute mode. And then the attributes that we varied for these were waiting time, travel cost, and parking cost. And essentially what we did is we first asked people just about choosing among conventional modes. So kind of as we did before, we thought, well, we'll try and figure out what are the parameters here if we don't even poison their brain with like thinking about autonomy. We're just going to ask them about these modes kind of on the merits of time and cost and so forth. And then afterwards, we asked them to make two more choices involving an autonomous mode. And so we were able to kind of separate those and do this analysis sort of where we got the same person making choices involving both conventional and autonomous. What we did not do, for better or for worse, and probably for worse, was we didn't ask that whole battery of questions about perceptions of safety. So we weren't able to do anything with that in this work. And okay, I've highlighted what matters, or what I thought mattered here. So we modeled we modeled the data with a mixed logit, and so we have heterogeneity in the preferences for autonomy in private cars, and so we have a sort of a negative mean but a sizable standard deviation around that mean in the effect of autonomy. So what that's telling us is there's Some people like the autonomy, some people very strongly dislike the autonomy. On average, there's a dislike for autonomy. And I don't know how much to trust this, right? I guess I'm not supposed to undercut my own work, but we found a positive utility for autonomy in the ride-hailing modes, and we didn't force those parameters to be the same in all of the ride-hail modes, but we see a positive mean, but again, sizable variation around that mean in the ride-hailing modes and sort of the preference for autonomy. And I'll come back at the end. We have some, we sort of check whether these are reasonable, by looking at the implied value of travel time. We did find that disutility of travel time was lower in cars and in transit than in the ride-hailing modes. And this was, I think, quite interesting. So respondents who identified themselves as females were significantly less likely to choose an autonomous mode, particularly, they were significantly less likely to choose an autonomous car. And then we calculated values of travel time to I believe these would be the means, to check the plausibility of the time and cost coefficients. It's peculiar because what we see here is that the value of travel time that we see here is higher for the autonomous mode than the conventional mode. That is consistent with what we've seen in prior work, and again, it's consistent with that idea that maybe people are not trusting the autonomy. But we saw sort of an opposite effect for solo ride-hailing trips. And so this is where we risk kind of drifting into the world of coming up, so like storytelling. And I guess I offer these up in the interest of transparency. I could spin stories about why that might be plausible, but I think we see this all the time, that no matter what the numbers come up with, we can come up with a story to tell about why we believe that. And so I want to be cautious not to overinterpret. And I actually shared some of these results in a talk recently that said, no, please speculate. We want to hear it. You said, okay, well, I'm just speculating. So if you guys want, I can expound on that. But again, we don't really know. We can hypothesize, but at the moment, really, it's just what the numbers tell us. Anyway, we took these and we then did essentially just a sensitivity analysis where we varied some of the key attributes of the price of conventional ride-hailing services, sort of a world where all the modes are conventional, and in a world where all the modes are autonomous. We then varied the price of the ride-hailing service. We reduced it by 10, so this is the percent reduction, so we reduced it by 10%, 20%, 30%, 40%, etc., and saw how did the transit mode shares respond to that. And what you see here is, okay, it depends on whether we're in the conventional or autonomous world, but really the transit mode share goes down, but the aggregate of transit and transit plus ride hail stays down relatively constant. I guess whether you consider that relatively constant or not is maybe in the eye of the beholder. But it was, we were sort of surprised that it did not go down more in this setting. So and this is where I think maybe some of these models might be useful if you're trying to sort of either build simulations or build algorithms for matching riders and with ride hail with first last mile, dispatching first last mile vehicles. Some of these parameters on preferences might be useful because we do get into we have that here. So travel time, we found the results were very insensitive to travel time. For reasons that are not immediately apparent to me. But what we did see was the waiting time, and again, the way we presented this is sort of the reduction or the improvement in waiting time. So we're going from longer waiting times to shorter waiting times here. And you see the transit mode, remains, again, relatively flat. Clearly the ride-hailing modes in the aggregate grow as you reduce the waiting time. So we did find that they were more sensitive to waiting time than to travel time. And so that, again, if you're trying to kind of dispatch vehicles, and if you want to account for treat as endogenous people's decision to use this service or not, this kind of thing could be handy. Anyway, so what we concluded from this work, and acknowledging that others might kind of look at those tea leaves and read it differently, but what we concluded from this was that ride hailing per se might not be a big competitor to transit, especially if you integrate it as a first last mile service. What we did see is some indication that if you have automated vehicles and you significantly reduce the price of ride hailing services, you might see some decline in total transit ridership. Particularly seeing a shift towards solo ride hailing. But interestingly, that if you also are able to reduce waiting times, that seems to help the transit and ride hail mode in particular. So that's sort of the conclusion of that work. And so that's that. And we can either do questions now or we can do questions at the end. Maybe I should plow through and then we can jump back to wherever folks want to go. Or do you want to ask questions now?
I would love to ask a question.
Yeah.
Can we have you pause for
Yeah.
I guess I'm trying to wrap my head around the model. So, like you said, trying to spin a story, right? Like the story that I feel like what I want to spin is like, I would rather have it be, like even if I don't like an autonomous vehicle, like and the technology makes me nervous in some way, which I think I actually fall into that bucket. So I thought your female part was interesting because my partner and I like debate all the time. Like there's various people in the department where I'm like, no, I'm not getting in one of those things.
We see that gender effect pretty consistent.
Okay. But when I think about it, like I'm not crazy about a driver. Right? Like the beauty of ride hailing is that I can sit back and do other things and whatnot, and and also that it comes to me, right? So I don't have to have a car, so I can bike or walk to work or whatever, and then I need to get home quick, I jump in an Uber and I can be home quick, right? Or my bus is late or I miss it or whatever like that, I can use it as a substitute. But I don't necessarily want a driver. In fact, in some ways, it makes me personally feel uncomfortable having a driver because I feel like I'm being driven, right? Like that's just, I guess, goes against who I am. So the idea, I'm like, well, I'd rather have automation than a driver. But I feel like that's not quite what the model is saying, right? That goes down because, automation is better than having a driver, and that's why I'm interested in your interpretation.
So here's where we landed when I went through this before, was, okay, so here's a story we can tell. So one is that when you go to autonomy, the value of time and savings goes up, implying that people would rather not be doing this, right? They prefer driving themselves to being driven.
Yeah.
And then in the, comparing, the conventional car and the conventional ride hail, there's a much higher value of time here, suggesting what you're saying, that people would rather be alone in the vehicle than have to ride with a driver.
Yeah.
But
it brings it back down with the autonomy.
But then the autonomy, when you move this to autonomy, then these start to look pretty similar.
Right.
So whether you're in a conventional, your own car with a robot driving, or a ride hail car with a robot driving, that's basically the same in-vehicle experience. So that's maybe how we square that circle. The difference here is not really statistically significant. We see this difference here now and so then we see the opposite effect, that is when you're talking about a pool trip, getting rid of the driver makes it even worse. And again, we've done some more recent work focusing just on the choice of pooled versus solo ride hail trip. And there, we've seen something similar, which is that people don't like the pooling. They really don't like pooling when there's no driver. In this other work, we looked specifically at the difference between conventional autonomous, solo and pooled, and how does autonomy affect that choice. And what we find is that women don't like pooling, women don't like autonomous, and women really, three reallys, really don't like pooled and autonomous.
Right. Because you're alone with a stranger in a vehicle.
Which, if I'd had to guess about choices, that's what I would have guessed. But we see this in the data, so that is not me making generalizations based on gender. That's what the data we have in this other study have shown. Again, we didn't get into quite that level of detail here, and in that work we have the what's interesting is we have there. It's a hybrid choice model, so we've controlled for things like, do you trust other passengers to behave themselves? Even after adjusting for that, we still see this gender effect.
Another thing that kind of makes me think of, about being in a car or liking a driver or not, is one thing I don't really like about Ubers and Lyft is a lot of times I feel like my drivers are bad drivers. Maybe not necessarily the person makes me nervous, but how they drive, they're really they're braking, or they're I feel like I'm gonna get a crash it's their car rather than my own. So I'm kind of curious if that's taken into account at all, and if any of your work has looked at the difference between ride-hailing Uber and Lyft versus hailing a ride maybe through a van partnership with a transit service. Because I would feel more comfortable, I feel getting in that kind of ride sharing than with an Uber driver, because those people I would assume are more trained.
So in this case, we did not. I might have it if we want to dig for it later. I might have the slide where we, just the language we use to introduce these modes. I don't think we really distinguished them. It was very much we didn't, be getting a sedan and ride to your destination, getting a sedan, same car, right, and same drive, right. I don't think we put anything. We certainly didn't put anything in there that would imply to people that it was a different type of vehicle or a different type of driver. It's not to say that people couldn't then, construe that anyway. But that's a good point, because yes, if you're using even just a different vehicle type, if it's a van or something, it could be a different in-vehicle experience. But yeah, that would be interesting. We did not really think about driving style and how people feel about an Uber driver. Although, right, I've got my theory. I've been wanting to do a speed study on my own street, because I feel like the cars that really bomb usually have a little black square with a name on it, windshield. But maybe I'm just, I'm seeing what I want to see, right? So,
Another question. I was wondering if you considered latent class models that might sort out people with opposite signs on some of these key coefficients. A membership model that will help.
I would. So that's a good question, Pat. I would have. Some of these start to blur together.
I understand.
And I would have to check with Lee. I believe on this one, we tried a latent class model and we just couldn't really get it to work. Couldn't get it to converge and give us results that seemed sensible. I was super keen on latent class for a while and had very good they worked very well for me. We've had a couple of studies where it's just we can't seem to get a latent class model to converge.
Yeah.
I don't know why. But in this case, we did mixed logic. I could check with Moeen if we tried a latent class, but it certainly didn't make it into the publication.
It can be very cool when it so clearly separates people with opposite signs, even, or at least major differences in magnitude.
Yeah, we've found them very useful is some of our EV charging work, and there we've done this a couple ways. In some cases, even just based kind of dropping insignificant predictors, which I always have mixed feelings about. But in some cases, we find that it's really it looks like Group A considers these three things, and Group B considers cost, but then two other things, right? Some people are basing it on how much excess range do they have, when you consider their state of charge and how far the next charger is. Other people are just looking at their own state of charge, period. So we've seen some pretty interesting stuff there where it's even you can see different, it implies that there's a different model of how they're thinking about range, and that's pretty cool. But, sometimes we do it and then we can't get the model to converge, and mixed logit often seems more reliable in that way. And again, you know, let's see, did we have anything on? So I think in this case, so we just had the two random turns, so on the intercepts and on the autonomy effect. Again, it's sort of like, it's always like, how much do we put in and how complex do we make the model, and then it becomes harder to interpret. I worry about sort of over-interpreting, as you might have got there, but we always want to see a pattern and make sense of it, but
yeah, this one doesn't seem over-specified, and the latent class is parameter heavy, but at the same time, in my mind, be more interpretable sometimes than the mixed logic, because you get a clearer sense of who has what kinds of coefficients. You know, at least you have a finite set of coefficients instead of an infinite distribution.
Right, yeah.
Coefficients that can kind of parse out who belongs to which set of coefficients. But, anyway, you tried.
I think we tried on this. Again, I'd have to check with Wayne, because he's been on a couple of these. Yeah.
So I assume the ride-hailing and transit are operated by different companies, right?
Yeah.
So I'm just wondering how much the ticket price will affect their choices. So because I probably need to pay twice if I take transit then ride-hail. But if I ride-hail transit ride-hail again, I need to pay 3 times, right? So I'm just wondering how they affect their choices in this model.
Yeah, so we did not disentangle those effects. We, again, in the interest of simplicity, we presented it as, and I mean, this was real ugly because we didn't have or didn't want to go to the effort of taking something like the work that you've been doing and fully integrating. You know, I think it's pretty cool that we're pulling these API numbers in real time to get realistic estimates of time and cost. But it'd be a whole other level to try and come up with realistic itineraries, essentially, of like how, where is the first mile service going to actually take you, right? So in a perfect world, you know what the existing transit itinerary is, and then you kind of in real time compute some alternative. If you have a first last mile that can go up to 1 mile or up to 2 miles or what have you, that'd be really cool. We didn't do that. We just said, I think what we said was cut off the shortest leg and replace it with Ridehail. Or we may have even just cut it by some arbitrary percentage of time. I mean, again, we're looking mostly at the marginal sensitivity of travel time. So in a sense, we felt like for purposes of understanding choice, we could assume that away and just suppose it saves you 10% or 30% of your travel time, and suppose it changes the cost from transit fare to $5 or $10. So we didn't, we just assumed that away. But where I think you really wanted to, so, and then where I calculate our market shares, this is basically just a sensitivity analysis based on the respondents we have in our sample. I do think a better way to do it would be to put it into a simulation framework where you can generate more realistic itineraries of like, well, for this particular person's trip, what is an actual ride-hail to transit itinerary that we could recommend to them and then model their choice. So it's pretty rough and ready on that side because the work was mostly about getting the data and building the model.
Thank you.
Does that answer your question?
Yes, that's it.
Anything else? Okay. So this project is focused on the curb, so more operational interactions, and sort of based on a hypothesis that there's interference. And again, Andy Shea was also involved in this, and Zach Amer is the PhD student RA who's done the lion's share of the work on this. And so this was the kind of motivation here was that there were a lot of anecdotes that ride-hailing drivers were blocking buses, using bus stops or stopping in the basically double parking to load and unload. And not only, but then Uber hastened to add not only ride-hailing but also urban freight delivery vehicles do this, so goods delivery. And so there was this notion that there was all this interference with bus operations happening. And so what we wanted to do was measure that systematically and then pilot some interventions. And it was building on earlier work that we had done, so I went looking for something about Uber and Lyft interfering with buses, and the top thing that came up was this story based on work that Ann Goodchild and I had done in sort of wave one of this work, where we looked at converting a bunch of on-street parking into passenger loading zones in South Lake Union, basically in the middle of the Amazon campus, and found that it led to more efficient pickup and drop-offs, essentially. But what we wanted to do here was then look more broadly in the city, and particularly at corridors where there were buses. And we kind of had this big vision that we were going to do sort of a pre-test and measure, measure, actually go out into the field, observe and code flag instances where we see buses being interfered with by other road users. We'd also be at the same time, ingesting huge amounts of data from King County Metro's GTFS-Realtime feed. And then, but really it was mostly about the field observation, deploy the countermeasures, whether it was going to be passenger loading zones or geofencing or some other tools that, that could be made up as we go based on what we see in stage one. And then go out afterwards and see if it made a difference. So kind of a pre-test, post-test design in the real world. And that's what we had done in South Lake Union. But then we're also thinking, at the same time, maybe as a bonus, we're going to have a bunch of GTFS-RT data. We're going to have a bunch of data on interferences. And maybe we can then start to see things, find ways to look at the GTFS-RT data and see indications of different types of interference. So maybe based on how much time a bus loses, that tells us about what the likely cause is. Anyway, it all got blown up by COVID. We'll get to that. But okay, so the first step was we took input from transit agencies, from Sound Transit, King County Metro, from SDOT and Bellevue DOT, from Uber, and from the general public. And we identified sort of all these places that sort of based on where the public said they'd witnessed problems while riding transit, based on the expert knowledge at these agencies. We identified these and we looked at basically among those which are ones that actually have a lot of bus ridership. And we had data that I can't show from shared streets on TNC pickup and drop-off locations. And so basically went in and overlaid all of these and picked out 10 corridors. And this is Seattle on the left and Bellevue on the right. This is downtown Seattle, the university's up there. This is Ballard, sort of an emerging, almost like second downtown area in Seattle, big urban village. And then over in Bellevue, this is sort of around their transit center in downtown Bellevue. And so we're going to study these corridors, and we set up this sort of app-based or tablet-based tool for field observers to kind of quickly code data. And we trained teams of undergrads to do this. And we sent them out into the field. Well, first we had to pause because then COVID, right? And so we paused this, and it got paused for like a year. And finally, they were like, just go ahead, just do it, right? Please just get this done, right? And so we sent them out this past March. And what we see is each of these is one of our study corridors, and the blue is the total number of bus arrivals that were noted by the field observers, and the greens are the instances of interference. So these were corridors we selected because we thought there'd be a lot of interference happening, and it's really not. We just didn't see it. So 22 instances of interference out of 1,600 bus arrivals logged. And then, again, this is frequency of bus traversals by site and frequency of instances of interference. Note the y-axes are very different on these. So that's up to 30, this is up to 2. So these are the average sort of rates of interference. And we actually saw 0 instances where we could confirm that it was a TNC vehicle interfering with a bus. There were some passenger vehicles that, they could have been TNCs, but we don't really know. And so we came back to the stakeholder group, and Uber was like, yeah, our ridership is still way down from pre-pandemic peaks. So, and between there being a lot less TNC pickup and drop-off activity, and just less travel activity in general still at this time, there's more curb space, so it's just like, okay, we're just not seeing this in a way we'd expect to see it. And so we essentially, at this point, suspended this part of the project because, again, overall demand is still low. And if you, our sort of the underlying assumption here is that this interference, the frequency of interference, is probably going to be non-linear in travel demand. It becomes a bigger problem when you're kind of operating at or near capacity. And again, TNC demand in particular is below pre-pandemic levels. So the part of this that we found that we considered successful was this collection and visualization of the GTFS-Realtime data. And basically this is allowing for sort of segment level analysis and visualization of bus performance. And so what we've been doing there is basically every 10 seconds pulling data in from the King County Metro GTFS-Realtime feed. Their system updates about every 30 seconds, so we're sort of sampling even faster than the buses are updating their positions. We put this into a database, and this is where Zach is really having fun, is putting it into a database and matching it to street segments is I think also a challenge. And then we put this up as a sort of a web tool where you can look at the whole network or pick out a particular route and then select a performance metric to examine for that route. The downside right now, and this is, I can go over to a live demo in a minute, but essentially the downside is right now we can only get it to like crunch and display like a day's worth of data at a time. So Zach has some ideas, and maybe we'll hire a computer science student or something, but I think we have some ideas that go beyond my pay grade on how to do this more efficiently, so that we might be able to say, look at an entire month of data at a time. So we've got all that data, we can analyze it offline. It just doesn't work for showing it in the web interface. But so right now it's sort of aggregated daily. We're looking at median speed, 5th percentile, 95th percentile speed, standard deviation of speed, change in schedule adherence. So when we see the buses like, it's always got, it's a certain amount ahead or behind schedule, and then how much does that change? So where does it shift relative to its schedule? So if we see areas where it's really volatile, like it's ahead of schedule and it's behind, it's ahead again, we see that as sort of a source of unreliability. So there's both a speed dimension and a reliability dimension here. And, okay, we can filter by route. And it's allowed us to kind of look back at our initial corridors. If we do end up restarting that part of the project or doing something similar in the future, I think we'll have this tool will give us a nice foundation for analyzing or selecting corridors where we really do see high levels of slow operations and unreliable operations. So where we're going next is try and speed it up to allow the online visualization of larger amounts of data, and maybe look at some alternative measures of speed and delay and reliability. So transit performance measurement is not my thing, and we sort of pulled some measures that made sense to us, but I think we'd certainly be open to suggestions on that. And here I've got,
It absolutely is our thing at T-Score though, Don, so I think you might have some people in the room who'd love to play with it.
Yeah, and
I
so
assume if it's coded to GTFS-Realtime, that essentially we could throw any GTFS-Realtime in there, or?
in theory you should be able to, and that's the whole point of this. Sorry, yeah, talk about burying the lead, Don. Yeah, the whole point of this was that because it uses GTFS-Realtime, you could have this tool or set of tools that you could then use for like any agency that has their data out through GTFS-RT. Then it's sort of a ready-made analytical toolbox. So we pitched that to WashDOT. There's about 10 agencies in the state that are using it right now, using GTFS-RT right now.
Yeah,
so we pitched to WashDOT, look, this is like something that can be useful to more agencies, and also would show the other agencies the value of getting their data onto GTFS-RT, like here's this analysis toolbox you can then use based on that.
But
So,
you had to integrate the One Bus Away API into there too? Like you couldn't do it just from the GTFS-Realtime?
as far as we can tell, the GTFS-Realtime is published through the One Bus Away API.
Well, that's how, yeah, in the Seattle area.
In Seattle,
that's essentially what it is, but, okay.
Yeah, so I guess how the GTFS-RT data is published then
Yeah,
might differ, and so you might have to do something
yeah,
different.
yeah.
But
Okay,
yeah,
but you're
so,
hitting the API for what you guys set up initially. So
yeah.
conceivably, I'm imagining that it's coded that anybody who's using One Bus Away at least could do this, but that's a handful of folks as opposed to, there's GTFS-Realtime coming out of several hundred agencies.
Yeah, and so this was sort of, we pitched this to Washdot, and I think we've been working on following up with the sponsor group that has supported it. And again, this has sort of gone a very different direction than the original project.
Yeah.
Like maybe more so than anything I've ever done. We've landed in a different place than where we thought we were going. But they'd said, Sound Transit in particular had said from the get-go, we'd love to see reusable tools.
Yeah.
And so we're like, okay.
Yeah, this is really cool. I'd actually love to have you talk about this part of it with the One Bus Away, the Open Transit Software Foundation.
Sure.
That means
Yeah.
monthly.
And
We
honestly,
can talk
if you
about
want to
it.
get into, I should really have Zach do it, honestly, because
Yeah.
he's
The one who coded it.
yeah, he's
Yeah.
coded it. He knows this so much better than I. Just like, hey, we have this
Yeah.
cool thing.
I'm like, yeah.
And so I guess what I can show you, right? So we can map these out and say, here's the median schedule change. And so how quickly essentially are they falling behind or getting ahead of schedule? And so I think it's sort of a proof of concept right now. I think really because it's only ever showing a day in this online version, pretty cautious, right? I think the value is in doing the same analysis with a month of data or 2 months or 3 months of data, which we can run offline at present. But yeah, and it was Zach had mentioned a desire to actually, if you were going to make this more widely usable, we need to have it not just be dependent on One Bus Away. So he has some ideas there.
Either that or we have to get on the ball and get One Bus Away used in more places.
Get it going. Yeah, and so this is, I think I kind of showed you in the slide. You pick out and again, the other thing that's cool is like you can pick an individual segment. So rather than looking at kind of reliability at the level of a route and focusing on, how does this bus do along its entire route, you kind of turn that on its head or turn it on its side and say, instead of looking at one bus, many segments, let's look at one segment and all the buses that are going over it. So it kind of turns the focus from the route to the specific infrastructure, which then gives us a way to identify sites, we think candidate sites for spot treatments, for instance.
Super cool.
Basic question, are you defining the segment by like intersections or?
It's street segments. Yeah. So actually, we don't have, so it would be the street segment like upstream of an intersection if you have like signal delay. But no, we don't actually have in the intersection coded. It's just segments that I guess go from the center of the intersection. But yeah, and so he used like the Tiger line file for the road network, and then again, sort of what was a little bit tricky was matching the routes to that. I don't think he used the GTFS shape data for that. I think he's just using the recorded bus positions.
Okay.
But I'm actually wondering, because that's always going to have some error in it,
Yep.
having that, if we use the GTFS route shapes, if that might then allow us to know in advance what segments should have a bus on it. Because we did do some work, and it's like part of it is like it wants to assign it to a neighboring street because that's the closest street, and so we had to do some filtering in these trajectory to figure out what the direction of the street's running and stuff. So getting it matched, you all who, if you've done GIS, you probably like matching is often the hard part. Poor thing, yeah. Anyway, and so we've got again schedule change and standard deviation of schedule change, and I don't know. So this is what we're trying to get at is ways of looking at. I think, and I don't know that these are the final set of measures. I want to keep telling Zach to do different stuff, but again, we only got so much influence, right? Especially when the project is straight this far. It's not like I can say, hey, the sponsors are expecting this, right? So, no, but I think, we want to see, where can we measure speed by, like, how much slower does it run on average than at free flow, the gap between 5th percentile and 95th percentile, and can we look at the standard deviation of speed or schedule adherence to capture, areas that are really unreliable. Anyway, so that's kind of where we're at on this.
Very cool. I think we're hitting up against 12. I think that's fabulous. We understand COVID interfering with research. We've had a few of our own experiences.
Yeah.
But it's cool that you guys were able to pivot. I don't know how amazingly publishable that would be, but I think I can put you in touch with more transit agencies that might actually be able to make it really useful.
Yeah, I don't know if this is something I'm supposed to say out loud, but I try not to let that stop me. I've had this realization, like, I guess I got promoted. I'm an associate professor now, and like maybe not everything I do has to be
super publishable.
Like,
Yeah.
I must squeeze 3 publications out of this project. It can be, do I think this is interesting, educational,
Yeah.
fun,
Yeah.
publishable is one consideration among many. I hope that doesn't sound like I've given up on publishing. But it's we'll do the work if it seems interesting.
Yeah.
And certainly the original project and the intent was, the sponsors, they really didn't care. But we're like, yeah, we want to get a publication on this. This, I don't know. We did get a TRB paper out of it last week. We got a couple of conference papers out of it. Again, I don't know. I don't know if it's publishable. It doesn't really matter to me.
Sometimes it doesn't matter.
If it's useful to the agencies and if the students are getting what they want out of it, whatever that is, then I'm happy.
That's cool. There may be some ways we could incorporate it in some of the stuff we're doing in T-Score too, so we'll make sure that the rest of the T-Score crew knows about it.
Yeah, cool.
Yeah. Well, thank you
All
very
right.
much.